Hi, it's Terry Dennery of the MathWorks. So as you can see, we're doing a yaw rotation on the vehicle, right? And we've seen it before in some of the earlier videos, all the propellers are spinning in the same direction, right? So we can do it, right? And you'll see in orange that rotation goes a little bit over 100 degrees. We tried to actually stop the propellers at 15 seconds, and you'll see that they're still spinning slightly, and so the rotation does continue. I'll just say there's some, I'll mark it down as probably some sort of stability issue, and I think we'll be able to address it when we bring more feedback into our flight controls. But at this level, I'm kind of content kind of with the idea that I know how to rotate this, right? Now, what I realized though, as I got into this, and in a way, this video never was intended to be recorded. I actually need to encounter this problem before I realized that there was one. So here's what we've applied for our torque, all right? And it was simply being sent directly into driving each of those propellers, right? Now, the controls basically take both the pilot and our trajectory, basically going from 0 to 2,000 meters in 100 seconds, and they convert that into commands that will be operated on by those local motor speed controllers, right? And so by disconnecting this, we're not really even accounting for any of that yet, right? So what I want to do is bring these in. Oops. Okay. And I'll just hit run from here. All right, and what you're going to notice very quickly is propellers are spinning, but there's no rotation in the vehicle, right? And it never does occur. And just kind of show you very minimal rotation. I think we get, 0.3 of a degree. All right, so what we're really observing here is that we have kind of a yaw command and we have a elevation, kind of Z ascent command, and that they're in conflict with each other. And we're applying that feedback control, with that PID right there. It's specifically taking that commanded speed, comparing it with feedback, and operating on that to produce a torque that will make the difference between the two nearly zero, right? And you'll see that we're pretty successful at that, as they seem to fall right on top of each other. But in doing that, we've actually limited our ability to actually send in a direct command on torque that will create that yaw, right? So kind of the necessity to create this was really, coming up with an approach to do yaw. And I realized that what it means is that the yaw command actually needs to go through that same, I'll call it thrust processing to operate with in the context of these controllers. And I'll also comment that it's not quite as easy as it is with pitch and roll. All right, so pitch and roll, it's all about having a torque that will kind of rotate the vehicle the right amount, and that torque is an R cross F, where F happens to be thrust. Well, we're trying to do a direct command on torque, and leaving thrust out of it actually is impossible. It needs to operate through these. And so the calculation of that thrust adjustment is a little bit trickier, and I'd say it's not quite as, I'd say, effective. And so anyways, we'll probably talk a little bit more about this in the next video, but I think with this one, I think it'll explain pretty clearly the choice that we'll make in the next video to control yaw by thrust adjustments as well. All right, thank you.